Hey guys, welcome to Master and Learn It. In this video, we are going to be focusing on differentiation from the first principle. What is differentiation? By the way, differentiation is just basically calculating the gradient of a curve. So, as I have already said, differentiation is basically calculating the gradient of a curve. But how do we calculate the gradient of a curve? Suppose we have a curve like this. So I'm just going to call it y equals to x squared. Remember, gradients defines direction. So we're not talking about gradient, we're talking about direction. So what is the direction of this curve? Can we define the gradient of this curve? We cannot, because at this point we can see that our gradient or the direction is increasing. But at this point, if I were to draw a line right here, you could see that the gradient is at this point is horizontal. That means it's not increasing. If I were to draw a straight line here, we would see that the gradient is decreasing. So in other words, the gradient of the curve is always changing to certain values of x. So how can we derive an expression that we can use to calculate every gradient on the curve? So that's basically about differentiation. So we are going to use differentiation from the first principles. From our curve that we have drawn already, let us try to put a straight line just going down. Remember, a straight line is denoted by y is equals to mx plus c, where m is the gradient or the direction. Remember, a straight line is just moving in one direction. That means its gradient is constant. It's just moving in the same direction. So suppose, let us say this gradient is 4 per se. Let us just say our gradient, let us say our gradient is negative 4 because it's a decreasing function. So that means at every point here we have a gradient of 4, a gradient of 4 every point. Notice that at this point, the curve and the straight line, they touch. So what do you think is the gradient at this point? If the straight line is having a gradient of 4 throughout, so what will be the gradient of the curve at the point where it touches or is a tangent to the straight line? The gradients are going to be the same. So this is a very important principle. We should know that the gradient of a tangent, a straight line that touches the curve, the gradient of a tangent is equal to the gradient of the curve at the point of intersection. So this is a very important principle that's going to build up everything that we are going to be doing. We should be able to know that we cannot calculate the gradient of a curve, but all we know is wherever a straight line touches a curve, wherever a straight line is a tangent to the curve, they share the same gradient. If this gradient is 2, then at this point this curve is having a gradient of 2. That's the first basic principle we should be aware of. So now let us use the same principle to calculate the gradient of a curve using what we call finding the gradient from the first principles. Remember, we know that gradient, I'm going to denote it by m, gradient is equals to y2 minus y1 all over x2 minus x1. So we are going to use this principle to calculate the gradient of a curve. Suppose I draw a curve right here, and this curve I'm going to call it y is equals to x squared. Then I have my y-axis right here, I have my x-axis right here. Then I have a point right here, which is, so I have a point right here, which is, I'm just gonna call it point B. So point B, suppose, is having coordinates of 3 and 9. These are the coordinates at point B. And I have the coordinates right here. I'm going to call this one point A. So the point A, you can see we're at the origin. So at the origin, the coordinates are 0 and 0. So now we are trying to find the gradient of this point. Like we said, we cannot calculate the gradient of a curve, but we need to draw straight lines, because we can calculate the gradient of a straight line. If I connect these 2 points, then I have created a straight line where I can apply y2 minus y1 over x2 minus x1. So I'm going to use the very same principle. So using this curve, my x right here is 3. So the first point, my x is 3, my x is 0, my y is 0 here, my x is 3, my y is 9. So I'm going to say y2, this is x and y, x and y. y2 is 9 minus y1 is 0 all over my x2 is 3 minus my x1 is 0. So when you simplify this, you get a gradient of 3. So now we have a straight line that gives us a gradient of 3. How about if I move, suppose this is 0, this is 1, this is 2. How about when x is 1 at this point? In other words, I have to draw at this point and try to draw a chord again. Remember, we're drawing chords because chords are straight lines. If we can be able to draw these chords as straight lines, we might be able to find the gradient of the curve. So now I have the coordinate when x is 1. What's going to be the corresponding y? At these points, I'm just going to put a line right here for you to see. When x is 1, then y, I have to substitute x into the curve. So I'm going to go and say, to get the corresponding y, y is equals to when x is 1 squared, which is still 1. So at this point, I have 1 and 1, which is my x and my y. Calculating the gradient right here, I'm going to say y2 is 9 minus y1 is 1 all over x2 is 3 minus x1 is 1, which is 9 minus 1 is 8 over 2, which is 4. So now I'll be having, here we got a gradient of 3. Now I'm having a gradient of 4. How about if I think of moving the points at this point? Let me try to draw a chord from here, just going to the point B, starting from here. What's going to be the gradient? Let us see what's going to happen, just using the same principle of a straight line, y2 being 9 minus y1. Remember, we are talking at the point when x is 2. So for me to get the corresponding y, I have to substitute 2 into the general curve. So I'm going to say y is equals to when x is 2 squared, which is 4. That means when x is 2, y is 4. Now we have these two coordinates. We can calculate the gradient right here. So now we are going to say y2, that's 9 minus y1 being 4 over x2, which is 3 minus x1, which is 2. So 9 minus 4, that's 5 over 3 minus 1 minus 2 is 1. 5 divided by 1, which is 5. So now we're having a gradient of 5. How about if you want to take this point further and say what would be the gradient when x is 3? Let us try to see what's going to happen. Now we had a gradient of 3, a gradient of 4, a gradient of 5. How about if we substitute coordinates when x is exactly 3? Let's see what's going to happen. When x is 3, to get the corresponding y, I go to my equation. Y is equals to when x is 3 squared, which is 9. So substituting our coordinates is going to be y2, that's 9, minus y1, so y1 is 9 over x2 is 3 minus x1 is 3, which gives us 0. So this doesn't make sense because here we had 3, 4, 5, so we cannot just say the gradient is 0. What can we conclude? We cannot substitute the x value at the point B because this is the same coordinate. So we're just going to look for a value just a little bit closer to 3, which is 4, which is a coordinate that is as closest to 3 is going to be 2.9. So let us just try to substitute 2.9. So when we substitute 2.9, just 1 second. So when we substitute using our calculator, just gonna go and say when x is 2.9 close squared, then we get the corresponding y coordinate is gonna be 8.41. So when x is 2.9, I'm just looking for the value that is closest. When x is 2.9, then the corresponding y is going to be 8.41. So now we have these coordinates from this point. Probably closest to 3 is somewhere right here at this point. That's getting closer, right? So we have in y2, that's 9, minus y1, which is 8.41 over x2 is 3 minus when x1 was 2.9. Then using our calculator we get 9 minus 8.41, we get 0.59 over 3 minus 2.9. Then we get 0.1. So 0.59 being divided by 0.1, then we get a gradient of 5.9. So what can we conclude? As this point gets closer to point B, remember it was at point A we got a gradient of 3, at point 1 we get a gradient of 4, at point closest to point 3, which was 2.9, we got a gradient of 5.9. So we're just having a gradient somewhere here of 5.9. What can we conclude? In as much as we increase values to make it 2.999, this gradient is tending to be 6. Is tending to be 6. In other words, what we can simply say, if I were to draw a chord very close here, if I keep drawing these chords, do you see that these chords automatically are going to be, if I keep drawing these chords, it was here, now it's here. When it gets closer, do we see that the chord is tending to be a tangent? So this is a fundamental principle. We have been drawing our chords as closest to this point. In other words, when the chord was tending to point B, then the gradient of the curve was tending to the gradient of the tangent. This is an important point because we know that the gradient of the tangent and the gradient of the curve, they are equal at the point of contact. So let us take this one further using algebra. So using algebra, suppose we have a curve like this and we want to find the gradient of this function. So let us say this point where I'm just drawing here is just having a coordinate of x. Remember, when we're drawing functions we use x and y. So this curve, I'm going to call it y equals to x squared. So now this point is x. So if I move from point X to this point, what will I call this point? Basically, in mathematics, we use the letter H to represent a small increase. So we normally use the letter H to represent a small increase. So what we're saying is, if this coordinate is the X coordinate or the X1, what's going to be the X2? The X2 is going to be the X1 plus a small increase of H. So if I were to write this coordinate, it's going to be X plus a small increase of H, which can represent our X2. So using this now, we can be able to calculate the gradient of a curve, a general expression that we can use to calculate the gradient of the curve at any point. Using the same principle, what I'm going to do, if I have, this is my X coordinate, this is my X1, this is my X2. So my X2 is X plus H, this is my X1. So this is my X1, this is my X2. If I want to get the corresponding Y at the X1, I'm going to substitute the X coordinate into the general expression. So I'm going to take X into, so I'm going to come and say Y is equals to taking this X, then what is the rule? I've squared it, so I get X squared. So that means when at X1, the Y1 is going to be X squared. If this is my X2, if I want to get the corresponding Y2, I'm going to take the X, Y equals to X plus H, then I have to square it. That will be my Y2. So my Y2, if I simplify this, is gonna be X squared plus 2XH plus H squared. This would be my Y2. Right, so if I am to apply differentiation from the first principle, so this is my X plus H squared, that's my Y2. So applying this same principle, we are going to apply this to say Y2, this is my Y2, X plus H close squared minus Y1 would be X squared all over X2 is X plus H, so X plus H minus X1, which is just X. So if we simplify this, remember we want to set a limit to come to a point when this H finally is going to be 0. So we're going to set our limit when H tends to 0. Let's clear these brackets. We get X squared plus 2XH minus X squared all over X minus X, that's 0, are left with H. So we need to check when our limit H tends to 0. From here we subtract X squared, subtracts with X squared, that's 0, are left with 2XH all over H when the limit H tends to 0. Then from here we cancel what cancels. X cancels with H, I'm left with 2X. This is the gradient function. That means suppose we have drawn our curve. If we know any X coordinate, we just substitute it directly, then we get the gradient. Remember in our first function, we had said at this point the gradient was getting towards 6. We can use this expression directly. If I want to find the gradient at the point when X is 3, I'm going to come and say the gradient is going to be, just substituting, we have 2X as our expression, 2, the X coordinate was 3. 2 times 3, which is 6, which is the same gradient that we calculated at the first. So in short, or in conclusion, if you are asked to calculate the gradient from the first principle, you just need to go to your X1. On your X2, just write X plus H. This is the first thing you need to do. Then what you have to do, you have to calculate the corresponding y value. For example, you are given a function that says, suppose you have a